Okay, so this is the second problem of this assignment. We're given that x observed the uniform function from -1 to 1, and we also know that there is a relation between random variable y and random variable x, and we also know that the density function of y, it's like that. It's actually exponential function plus when y is larger than 0. We need to find out the function of the random function, the functional relation of y and x. Well, actually, this is just a simple implementation of theorem in Papuli's book, so there's no need to stress the proof here. But so we're gonna just simply take it this way: if x is a if x if g if the relation of y and x are a function of the probability function of x, then the density function of y happens to be the uniform function. Well, this is they could just simply use the fundamental theorem to deduct that. I'm gonna deduct it here. So the conclusion is, if we wanted to know y, so y is just simply the inverse function of the probability function of y. So if we're gonna implement this to this, it's very easy. We just integrate, do an integrate the density function of y. So we just go like this, and did a little. After we saw working out fy, a big capital Fy, we could just do the inverse. We could try to find out the inverse function of big Y. So we get like that. So the inverse function of big Y is our final answer. It's like 1 - 1/2 ln y minus x. So take a look at the area where x is defined. X is between -1 and 1. So you could see that this relation, so this functional relation, is valid. So we actually from another angle, it verifies our answer.